This is a quick introduction to parabolas in vertex form. Y minus some slide is equal to A, usually a shape, times x minus some slide squared. That's a little complicated. We're going to look at that soon, but first we're going to start with what we know. Y equals x squared, a parabola. I've graphed it here. We know that if you go over 1, 1 squared is 1, 2, 2 squared is 4, and we have a parabola we're very familiar with. I want to now look at what happens when you subtract something from the y and subtract something from the x and square. If you look at this equation and think about what point might be on this, if both sides equal 0, when 0 equals 0, what values might we see that would make this true? Well, if y equals 1, 1 minus 1 is 0, so that is an easy point to see. And if x equals 3, 3 minus 3 is 0, and therefore we know that if x equals 3 and y equals 1, we get 0 equals 0, which means we have a point on the curve 3, 1 that makes the equation true and is therefore a point on the curve. So the point 3, 1 is a point on the curve, approximately there. Now, if this were just any old point on the curve, that would be kind of tough to pin down. But if you solve the equation for y, you get y equals 1 plus x minus 3 squared, adding 1 to both sides. This quantity is something squared. Well, it's always non-negative. It's always greater than or equal to 0. Therefore, y is equal to something which is 1 plus something greater than or equal to 0, which basically means that it is going to have to be greater than or equal to 1. Well, that tells us then that this curve not only goes through the point 3, 1, but has the smallest value at 3, 1. So the graph itself must be a parabola that comes down to that point and goes up. Well, let's just make sure of that. So we'll graph this parabola here. It goes through the point 3, 1, and indeed that's not only just any point on the parabola, it's the vertex of the parabola. Now note also that this parabola had a shape of over 1 and up 1, and if I go from the vertex here over 1, it goes up 1. If you go on the one at the origin over 2, you go up 4, 1, 2, 3, 4. And on this one, if you start at the vertex and go over 2, you go up 1, 2, 3, 4 as well. So it has the exact same shape. It just goes through the point where both sides equal to 0. And that point is the vertex. Well, what happens if we play around a little bit with these numbers? If we change this number to a 2 and this number to a 3. Well, now the vertex is 2, 3. When x equals 2, we get a 0, and when y equals 3, we get that side equals 0, so it goes through point 2, 3, and that's the vertex, and it has the exact same shape. What happens if we play around with the shape a little bit? What happens if we make this y equals 2x squared? The red curve has been made twice as steep, everything got multiplied by 2, and the blue curve hasn't changed yet, but that's because we haven't put in the multiplier. All of a sudden now, the red curve and the blue curves have the exact same shape. If you start the vertex, go over 1, you go up 2. If you start this vertex and go over 1, you go up 2. So it has the exact same shape. Does that always work? We make it a 3 for the red, and a 3 shape for the y. For the blue, when we go over 1, we go up 3. On the blue, when we go over 1, we go up 3. So, when we look at this form now, this constant is talking to us about the shape. What shape does the parabola have? And then this slides it right and left, and this slides it up and down. let's take a little bit further look in this. Here I have the parabola of y equals ax squared, and here I have the curve shifted. And I want to just quickly draw y minus 3 equals 2 times x minus 5. When we look at it, this side equals 0 when x equals 5, and this side equals 0 when y equals 3. So if we go to the point x equals 5, y equals 3, we get a point, we might get a point that's on the curve. There we go. And what do we expect for the shape? Well, it's a shape of 2. If we go from the vertex over 1, we expect to go up 2, over 1, up 2. If we go over 2, 2 squared is 4, but times 2 is 8. 6, 8. We expect it basically to go through these points. I'm picking up the symmetric point. Well, let's see. If I take this curve and graph it, it's just the blue curve, but that's because over here I haven't shifted it yet. I have to make h equal to, I'm going to move it over, 5. There it is at 5, and the k, the y shift is 2, so I'm going to shift it up 2. Up 3. And that lines up actually with the dots that we put in there. Let's see the dots. If I move it down, move it up 3, as predicted, goes through the dots we predicted. So if we change the shape, this time I'm having both curves change shape because they both have the same a, whatever a is, and if a is 0, you get a line. It's not a quadratic equation. A equals 1, a equals 2, a equals 3. They both have the same shape. If you don't slide at all in the x direction, then there it is, lined up with the same x values. If you slide it 1, 2, 3, 4, 5, it goes off to the right. You want to slide it to the left. Y minus a negative is going to be actually look like a y plus, and it would slide off to the left. We'll make it back to the 5 we had. And if you slide up and down, it's what you're taking away from k. It slides up and down. So when you're drawing these curves, you basically want to think about, okay, it's the red shape that's been moved. Where has it been moved? It's been moved to the point hk, x equals h, y equals k, and that's where you start in drawing the exact same shape you would have drawn back at the origin. That's the idea. We're going to put this into practice. Hope this makes sense. It certainly will with some homework.